I'd like to take a look at one of the problems that was assigned for homework concerning the before and after weights of women before pregnancy and then 10 years after pregnancy. And the question was, did women recover their weights 10 years after pregnancy? This is a before and after scenario, and so the null hypothesis would be that there's no difference, that the before weight is the same as the after weight. And the alternative hypothesis would be that the before weight is less than the after weight. We have suspicion to think that the before might be less than the after, and so we use a less than sign. If I write this in terms of a difference, this would be that the difference is 0. And for this one, it would be that the difference is less than 0. Okay, so to proceed, we find the differences, and that'll be B1 minus B2 here. And then if I fill the pattern across, there's the differences. And so the average difference, now that I have those differences, I can basically start scrolling down. Now that I have those differences, what's the most important thing are the differences, not the numbers. So I can basically forget about what the befores and the after were and just simply look at the differences by themselves. The average difference will be equal to the average of these 20 numbers. So about negative 12, if I get a few more places, negative 11.6. While the standard deviation of the differences is equal to 13.43. Our alpha value will be equal to 0.05. And in this case, our t statistic will be equal to negative 11.6. The average difference, the observed difference, minus the expected difference, divided by the standard error for the difference, so 13.43, divided by the square root of 20. So that gives us a t-value of B4 minus 0 over the standard deviation divided by the square root of 20 for a t-value of negative 3.862. Alright, and as always, there are two ways to proceed. The first way is to figure out the p-value. This can be done in Excel or else on a TI calculator. So the p-value would be equal to t.dist of that number that we just got, B6. In this case, I have 19 degrees of freedom, and I do want it cumulative. So that's the command using Excel. A similar command using TI calculator was described in another video, and we get a p-value of 5.3 times 10 to the minus 4. P-value equal 5.3 times 10 to the minus 4. That's a small value, and so that would lead us to reject the null hypothesis. The other way to do this is by getting the critical value. And the critical value is equal to t.dist, for the left-tailed critical value, of 0.05 with 19, t.inv, pardon me, t.inv of 0.05 with 19 degrees of freedom, which works out to be negative 1.7291. So that would be the picture over here. If I specify the area in red to be equal to 0.05, then the critical value is equal to negative 1.7291. This can also be found on some calculators, and it also can be found using the table in the textbook, using the 0.95 line on top and then using the negative value. Okay, in our case, the critical value, the test statistic is negative 3.86, so that falls over here, and so the decision is to reject the null hypothesis. So our conclusion is that we reject the null hypothesis. So we reject the null hypothesis. It appears that the after weights are larger than the before weights. And we used a paired t-test because this was a before and after scenario as opposed to something which was not paired.